All right. So if somebody's gone, there's vocab words, push pause, and write them down. But now we're to here. Okay. Points are on a circle. Okay. If we have 1 point, there's no line to connect, so there's one region. If you put 2 points on a circle and connect them with a line, it divides it up into 2 regions. If we put 3 points on a circle and connect them all with lines, there's 1, 2, 3, 4 regions. If we put 4 points on a circle and connect them all with lines, it makes 8 regions. So then, if we put 5 points on the circle, how many regions will we have? If we put 5 points on the circle, how many regions are we going to have? Not 12. Good guess, though. Good guess. 16. 5 points is 16 regions. Why? Because you do 8 times 2. That's an okay reason, but I need a more detailed reason. Braden.
Well, in one region there was 1, and then you added 1 to get 2 regions, and then from 2 to 4 regions you added 2, from 4 to 8 you added 4.
Okay, so they have 2 different methods of doing it. Okay? You did what each time? Kendra multiplied by 2 each time. And then got 16. Braden first added 1, then added 2, then added 4, then added 8, and then next time he would add 16, and so on. Okay? All right. So it's basically the same thing. Both of them used what was called inductive reasoning, which is a type of reasoning that reaches conclusions based on a specific pattern of past events. Okay, just go that far when you write down your definition. A type of reasoning that reaches conclusions based on a pattern of specific examples or past events. Okay, so let's use inductive reasoning to figure out what the next 2 numbers are. 88, 82, 76, 70, 64. So, what would be the next 2 numbers? What do you think, Jenny? Look at that pattern. See what's happening. 94? No, we're not going up. We're going down. 56? Not quite. You're really, really close. A lot closer than last time. Nick, what do you think? 58. Next number is 58. And then it would be 52. What's happening each time? We are going down by 6. Going down by 6. Going down by 6. Okay? So, what we're doing is we're making a conjecture, an unproven statement or rule based on inductive reasoning. A conjecture, vocab word, is an unproven proven statement or rule based on inductive reasoning. Now, conjecture is a very fancy word for what? What's a 5-letter word that it's a very basic word that conjecture is a fancy word for? 5-letter word. Starts with a G. A guess. A conjecture is basically a guess. You're guessing to see what it is. Now, most of you take educated guesses, okay, that are correct guesses, but if it's not proven, it's still just a guess. Now, let's look at the pattern here, okay? In the first term, there's 2 dots. In the second term, there's 6 dots. Third term, there's 12 dots. Fourth term, there's 20 dots. How many would there be in the fifth term? How many dots? Not 25. 30 is a guess. Do we trust 30 as a guess? I trust 30 as a guess. Okay, more than one way to do this. Okay. What happened from 2 to 6? I go up by 4. What happened from 6 to 12? I go up by 6. What happened from 12 to 20? Go up by 8. 20 to 30, I go up by 10. Okay? Go up by 10. Another way to do it is, this is 1 by 2 to give you 2. This is 2 by 3 to give you 6. This is 3 by 4 to give you 12. This is 4 by 5 to give you 20. This is 5 by 6 to give you 30. Okay? Now, they want the nth term of this pattern. Okay? The nth term. How do we get the nth term? Well, it's 2n where is it? Just a second. How would we write this as an algebra formula? Because we add 4, add 6, add 2. So it's the previous term plus 2 more each time. So the term number is 2. That gives us 6. That's like 2n plus 2. But 2n plus 2 would not work for this. 2 times n plus 2. Nope. Okay. Well, we figured out the pattern, at least. What does these look like? An arrangement of circles, but how about bowling pins? Is that how bowling pins are arranged? Those of you who ever bowled before? What if you would add another row? Well, how many pins are here right now? 10. What if you would add another row? How many would there be total? 15. Okay. All right. In this table, shows water is heated at a constant power. What do you see? What do you see that's happening here? It's increasing by how much? Is it 4.7 every time? Sure looks like it. Okay. So after 16 minutes, what should the temperature be if it's increasing at 4.7 each time? Well, you take 4.7 times 16, and then you have to add on what to that? 20.1, the initial temperature. Okay, 4.7 times 16, it's 75.2 plus 20.1 gives me 95.3. After 16 minutes, it should be 95.3 degrees, right? Okay. All right, let's look at a counterexample. All right, we're looking to prove something false. So here's a vocab word, okay? And I can't zoom that in. A counterexample is an example that shows a statement or conjecture is false. A counterexample is an example that shows a statement or conjecture is false. All right, so we're going to look and see if we can find a counterexample to this statement. Okay. The statement is a polygon with diagonals has two fewer diagonals than sides. So if it has four sides, it has two diagonals. It's true for a four-sided figure, right? If we look at a three-sided figure, does it have any diagonals? No. So it's false for that. If we look at a five-sided, it has five sides and five diagonals. Is it true for that? No. So a polygon with diagonals, when you say it has two fewer diagonals with sides, it only works for a quadrilateral. It doesn't work for any other shape. So we know that conjecture is false. That's a false statement. Okay? All right. So what we did today is worked with inductive reasoning. We looked at patterns, we made a generalization in our head, and then we came up with a conjecture. What happens each time? Now, if you come up with a counterexample to say that doesn't work, then you know your conjecture is false. Okay? So that's what we're doing. So, okay, I am going to set you out on your assignment today. You have a bunch of time to work on it, 50 minutes basically. So you should not have a problem getting it done. Let me go here. All right.
Probably want to stop the recording.
Probably.